Welcome to Haslip CycleWorks. I'm Robert, and in today's episode, I'm going to show you guys a new tool that most of you probably never considered, but maybe should have. Okay, so this tool is rather unconventional. At least it is right now. You see this a lot in some of the more custom shops, a lot of the real high-end shops. I'm not going to throw any names out there, but you can do your own research and see what I'm talking about. And a lot of manufacturers are starting to use this process when they're testing, designing, and fabricating things for the first time. So without just coming out and saying what it is, I'm going to show you some stills and some action shots of this tool working. I know. 3D printers. Wait, come back. Now hear me out. I'm going to tell you why you might want to consider a 3D printer for your garage or shop. No, don't worry. I haven't been out riding without my helmet on. I haven't been hitting the head. And initially I probably thought the same way you guys did, until I did a little bit more research and saw what a 3D printer can actually offer us as fabricators. The parts that you get from a 3D printer, at least the version of the 3D printer that I purchased, which was the Ender 3 Pro, they're not going to be your final part. What we're going to use it for here is for quick prototyping and proof of concepts. Now, there will be a few cases where you can use the part that comes off the printer directly. There's no post-processing, there's no using it for anything else. Let me show you something. Okay, this is one of the demos that came on the printer. It's a little 3D dog, pretty sweet. And if you look, it's got some sweet detail to it. Okay. And another thing, just to show the scale at which you can print. It's a little rocket with the little blast plume and vapor trail and all that. That is actually 3 pieces that I had to glue together. So 3D printers can get down to some very small scale. Yeah, I know. Okay, Robert, you were talking about how you can use a 3D printer in the shop or garage. Why are you showing us toys? Well, those are just a couple examples. Now let's say you've got a mini bike, mini trike or something along those lines. It's powered by a small motor. And let's say the scenario is someone's calling you out. Now you got a drag race. It's tomorrow or this weekend. And as much as we would like it to be, this is not the Fast and Furious. We cannot next day order parts from Japan, okay? It's just not a reality. So, you think you got this guy, but your motor starts to bog on the top end. Could it be your air filter is choking your motor? Well, you're not going to run it without some sort of air filter or velocity stack, right? Because then the air is going to come in, it's going to swirl, it's not going to be a smooth transition, and it's probably going to make matters worse. But if you had a 3D printer, you could print your own velocity stack. Now, this was a 3D print file that I found online for free. But as you can tell, there's a little bit of errors, and of course it's the wrong size. So what do you do if you 3D print a small part like this and it's wrong or it screws up? you throw it away because it costs you less than $1 in materials to print that. So then you use one of the many plethora of software titles to choose from that are free that will allow you to take a 3D printed file, usually STLs, and slice it up in the G code, which is the code and commands that the printer understands. So it can take a visual that you drew or someone else drew in 3D, and it slices it up into the layers that a 3D printer will actually print. And it tells the print head where to move to print such item. Most of those will allow you, and they're free, but it will allow you to scale and correct those errors. So this is the exact same file, scaled up just a little bit. No errors. And the Venturi, smallest part of the Venturi, is going to fit for our theoretical application. You print this out, you slap it on your carb, and you go gap the dude. Mission accomplished. And you've got less than $1 worth of materials. The only thing that it took away from you was time. Now I will tell you, most of these 3D printers are slow. But this is cheaper and quicker than purchasing a block of aluminum, measuring everything 2 or 3 times, and that block of aluminum is going to be expensive. Measuring it all up, drawing up your design, taking it to a machine shop, and having them mill it out or put it on a lathe and spin it up for you. If you got those tools to do it yourself, that's great. But the cost of that aluminum, it's going to be up there. So that's one case. Now, another case that kind of fell in my lap here was I have the Harbor Freight blast cabinet, right? And those, we're going to do a whole separate episode on this about dust collection. The hole in the side of that cabinet that you use to attach a vacuum source is a pretty large hole. And the only vacuums that I've been able to find that the hose will fit directly into are like rigids. And everyone knows rigids are expensive. And I'm not going to spend $200 or $300 on a shop vac. I do have a little $40 no-name brand shop vac that would work fine. But there's a huge discrepancy in size between the hole in the side of that cabinet and the vacuum hose. You go spend $20, $30 at the hardware store buying PVC parts that might fit, that you have to then glue together, you might have to whittle down. Or do you go to your 3D printer, look online, and find exact parts you need, and then print it out? A couple hours later, done. Now this one was printed on a different process, on a different type of printer by our buddy Jason over at CodeMakesItGo. Literally a couple dollars in materials and our problem solved. The cost of one of these little 3D printers, and I'll put a link to the one that I have down in the description, less than 300 bucks, and you hit the ground running. It can help speed up your prototyping, make it easier, and you're not going to spend or waste as much money trying to make something as the final product, and it just simply doesn't work. 3D printing is not the golden goose egg. It is not the end-all, be-all to fabrication. Is it a stepping stone to help you get to a certain point? Yes. Is it a replacement for a plasma table or a lathe or a mill or any sort of tools like that? No. It simply complements those tools to help speed up your design and your production of prototype parts. This episode was meant to be just an introduction to the concept of 3D printing for fabrication. Yeah, I know, wardrobe change, battery wasn't charging the camera, gonna have to fire the camera guy. So just an introduction, just kind of showing you and kind of get you to think about where you might be able to use this and how this process might make things easier for you. There will be more episodes about this, and in those episodes we're going to do a couple things. One episode I'm going to show you how you can use a 3D printed part to make a metal part from. I'm also going to show you how to take, because this is a plastic that is not suited for high temperature situations, I'm going to show you how to turn this into a different type of plastic part that will better suit your need. And then of course we're going to take some 3D printed parts and cover them in fiberglass or carbon fiber or something to make some aesthetic panels for bikes and stuff like that. And we're also going to do a really cool project with CodeMakesItGo using some of his coding and some other hardware. So if this kind of tickles your fancy, definitely make sure you subscribe and stay tuned, because we're going to be doing some pretty sick stuff. So until next time, guys, get up, get out there and do it.